All right. Now we're going to talk about volume of a cone and a sphere. All right, so this is a cone. Think ice cream cone. And the formula is 1/3 pi r squared h. And then we have a sphere, 4/3 pi r cubed. Okay, 1/3 pi r squared h and 4/3 pi r cubed. All right, we have an ice cream cone. It is 5 inches deep and it has a radius of 1 inch. And we have a scoop of ice cream, looks like strawberry, that also has a radius of 1 inch. So the question is, if the ice cream melts into the cone, is it going to overflow? Well, anytime we talk about stuff inside of a three-dimensional object, we're talking about volume. So we have to find the volume of the cone, which offhand I don't remember the formula. 1/3 pi r squared h. Okay, so 1/3 pi r squared h for the ice cream cone. And then we also have to find the volume of the ice cream and basically see if the ice cream has more volume than the cone. Okay, so if the ice cream has more volume than the cone, then it will overflow. All right, and the 4/3 pi r cubed, that's going to be for the ice cream. C-R-E-A-M. Okay, so yeah. Now that I figured out how to change the color. Okay, so we're going to do the ice cream cone first. So we have 1/3 pi. It says it has a radius of, where's my cone? Radius of 1 inch. 1 square. This is the cone now. And the height, and it's 5 inches. All right. And let's see. So 1 times 1 is 1, times 5 is 5, times, use the pi button. I get approximately 5.2 inches cubed. It is volume. We got to use inches cubed. All right, so that is for the cone. That's for the cone. All right, and now we have to find the volume of the ice cream. So let's use orange. The ice cream, 4/3 pi times the radius. Again, the ice cream also has a radius of 1 inch. So 1 cubed. 1 times 1 times 1 is 1. So what we are looking for is 4/3 times pi times 1. And it looks like that is approximately 4.2 inches cubed for the ice cream. E-A-M. All right. So the cone has a bigger volume than the ice cream. So since the ice cream has smaller volume than the cone, it will not overflow the cone if it happens to all melt. Although why would you let it all melt? I don't know. But anyway, so okay. Now be careful with surface area. Think of surface area as like an empty cardboard box. And we are looking for just the cardboard. We don't want to know how much we can put inside the box. We want to know how much cardboard we're going to have to use to create the box. Okay, so it's just the walls of a three-dimensional object, just the walls. All right. So think of it this way. We need the area of the top wall of the box, and we need the area of the bottom wall of the box, and we need the area of the side wall of the box, and we need the area of the opposite side of the box, and we need the area of the end of the box and the area of the end of the box. Notice I had a top and a bottom that was the same, and I had two sides that were the same, and I had two ends that were the same. So that's why we have two of these, two of those, and two of those. Okay. With a cube, we've got 6 sides that are identical, and the area is side times side. So we've got 6 of our s squareds. With the circular cylinder, remember pi r squared is area of a circle? That's the top. And then we also have a bottom that is the same. That's why we've got 2 of them, 2 pi r squareds. And then this represents, think of this as a can. This represents the walls of the can. All right? I'm never going to remember those formulas. I don't expect you to remember the formulas. You can write them down and use a note card for the formulas. All right. So we have this rectangular solid, and we want to find the surface area. By the way, one thing that you would use surface area for, like in real life, is to paint a room. Let's suppose you're going to paint all of the walls and the floor and the ceiling the same color. You generally don't do that, but let's suppose. Ignoring windows and doors and all that kind of stuff, surface area is the amount of, would determine the amount of paint that you would need to purchase. The reason why I bring this up, I used to have students do a group project where they had to calculate how much paint they would need to paint a room. And every single group, every single time, found the volume of the room and gave me some sort of crazy answer like 20,000 gallons of paint or something crazy like that. Well, if you were to pour out a gallon of paint, 20,000 gallons of paint into a room, sure enough, you would fill that up with paint, but that's really not how we generally paint a room. We usually just paint the walls. So that is surface area. Okay, so surface area gives us the surface of the area of the wall, right? Or the area of the surface of the wall. Okay, so I want to find the area of the top, and I want to find the area of the bottom. They are going to match. So the area of this is 8 right here, and this is 5. So to find the area of the top would be 8 times 5, which is 40. But I've got 2 of those. I've got the top and the bottom. So surface area, I have 2 of my 8 times my 5. That's the top and the bottom. Now I need the area of the sides. So this is 3 and this is 8. Okay, so that will give me this side, but I also need the back side as well. So I've got 2 of my 3 times my 8. And now I need the ends. Okay, so this is 3, and this is 5. So I've got 2 of my 3 times my 5. So 8 times 5 is 40, times 2 is 80. 3 times 4 is 24, times 2 is 48. 3 times 5 is 15, times 2 is 30. And guys, there's no rhyme or reason why I did the 8 times the 5 first. It really doesn't matter. You could do 2 times 8 first and then multiply it times 5, whatever. But I find it easier to multiply by 2 last because it's easier for me to double something. But it really doesn't matter. As a matter of fact, you can probably put that in your calculator. So 80 plus 48 plus 30 is 158. Guys, we're talking about area, right? Area. It's not going to be yards cubed or cubic yards. It's going to be yards squared. Yards squared, okay? Because it's area. And there you go.